Good morning, Dabblers. Welcome to our fourth session of the Dabl Club DevCamp. We appreciate you joining us on this historic and conveniently synchronized Bitcoin Pizza Day. So congratulations, and I hope everyone has a wonderful day all over the globe. If you're involved in any of the Pizza DAO parties or anywhere else you might be celebrating, get you a slice somewhere, wherever you may be, and happy Bitcoin Pizza Day to you. Mel was just explaining to me that we've got a big curriculum ahead of us, so I'll let him dive right into explaining that. But by all means, we appreciate you being here and dabbling with our dev camp.
Yes, thanks, Kale. And like you said, Pizza Day, make sure there's going to be a lot of cool meetups and just get around and eat pizza. There's one today here in Mexico City, so I'll look into heading out there and taking a look and meeting up with some of the cool community members around here. And yes, today we will continue with our fourth session for the Dev Camp with Onchain fundamentals. Last session we went through some smart contract development. We will start from scratch so we can do like more step-by-step, easy to get into these smart contracts for the NFT, the ERC20, and the vault. And we will complement with the in the vault to allow some integration for Uniswap hooks. We will first, not Uniswap hooks, sorry, Uniswap swapping methods. We will take a quick detour to go through the Uniswap example first, so we can get some context on what Uniswap does and how we can start reviewing their documentation and going through some of the methods that we will be integrating. So first, we will review what we were building before. So let's take a look here and share some share diagram, the current implementation, what we have. So this is what we are currently developing. So last week we were able to deploy some of these contracts. However, our testing with the live, because of the decimals and some of this stuff that we haven't been very careful about, just because of speed, we will be redeploying these contracts on our local network first, see that that they work well, and we will complete with the real estate NFT for the ERC721, the ERC20 token, and the vault. And within the vault, we will implement later these hooks that, so we can, instead of sending some like monthly earning strategies, we can send liquidity to a pool, to a Uniswap pool. That's something that we can do. So this is a new integration here. Instead of the strategy, we're going to be connecting to Uniswap protocol. And we will be diving also into seeing exactly what the Uniswap protocol is. So just a freshener of what we were building before. We are building our tokenization, our real estate tokenization app that allows anyone to tokenize a real estate property as an ERC721 token. That's what we have here. So we can have different tokens, each of them, each NFT representing a different property with different information, location, and everything, price. After that, we emit or we tokenize. First we tokenize as a one of one, but then we can tokenize the shares for the real estate and convert them into a divisible ERC20 token, where we can fractionalize the real estate property into 1,000 shares. And those shares, then we can, owners of those shares, that can come in and buy into the property, they can come and deposit their tokens on a vault. And the idea is that this vault will generate some yield on top of those tokens. So one of the ones that we were discussing the previous session was on renting it out and being a little bit more off chain, just earning money and depositing their earnings into the vault. However, there's another option. You can, these are strategies, and you can execute pretty much any strategy that you want inside your vault token, and and that's what we will be looking to instantiate with the Uniswap pool, so we can send some liquidity to this Uniswap and simulate another strategy where we can integrate Uniswap through the liquidity provider, or even doing some swaps in the hooks that we have available on our ERC-4626 smart contract, and see how we can provide with additional benefits to the users of the app. It can be accepting any, accepting ETH, accepting USDC as a way to also, like, to, let's say you wanted to buy some of these tokens, you can do it directly through the vault, or converting them into USDC, so we can have 50-50 deposits on the protocol for, let's say, a pool that will have our tokens, these 1,000 tokens, and USDC. We could allow that to happen before executing the transfer, or within the very same Uniswap protocol. So first, we're going to review the Uniswap documentation. And the reason why we're starting with the Uniswap documentation is because we're going to go through the first, getting started contract with the swap. And we're going to test a couple of things and see that we can actually execute it on our new repo. We're going to start a new repository with the same, and with scaffolding 2 as well. So move this over here. And using this here. And Dabl. No, one to up. And okay, so here we can copy this command and start again. I'm gonna do it faster each time. You're gonna get used to, let's see, DevCamp week 2, session 2. We're gonna be using hardhat, remember? And what we will be checking here on this, the new version was launched, I believe, last year, and there are some concepts that have changed, and I want to show the better diagram is actually in V3. No, it's not here. Concepts. It's actually a very good video that I recommend. You can also check it out. But there was like a very easy to understand. I'm not finding the diagram now. Thanks. Anyways. Could have sworn that I was reading just before. Yeah, let's go to the core implementation. So yeah, I can draw the diagram myself. So basically, what you have is a smart contract that, I mean, a lot of us have used Uniswap before, so maybe it's easier to just show on how it works. It's a decentralized exchange that functions as an automated market maker. So the idea is that you can deposit tokens into a pool if you want to be a liquidity provider, and these tokens are paired. As an exchange, you want to switch maybe ETH for USDC. So you can just select pairs and exchange them for whatever you want to Why am I not getting my? Okay, the frame one. It should over here. Uniswap.org. So, for example, something like this. And I can swap some USDC for some, let's say $10 for some ETH or any other token that's available on the as part of the liquidity provided. So there are some things that we can get around. There's a lot of tokens and a lot of chains. So basically, what you do is I want to do for another ERC20. So let's say, yeah, Bitcoin. The way around. This is very high price impact. It's okay, it's only $10. So I'm actually gonna receive a lot less. So maybe I shouldn't do it on mainnet. But yeah, let's switch chains. Polygon. We have some USDC here, and let's get some Uni token. It's actually available as well here. So you select your tokens, and you can swap them very easily. So we call the contract, we sign it, and that's what, that's like the interface. And what we usually have on Uniswap as part of the protocol is all of these, pools that we have available, all of these pairs that we can deposit liquidity pools. And we have like here we have other, this is part of like what they call the periphery smart contracts. So like the core smart contracts on the protocol that handle core protocol or Uniswap. It handles things like liquidity pools, swaps. Like the proper implementation of all of the logic is part of the core protocol. That's smart contracts, and you can check them. And close the docs. But technical reference. Contracts. Doesn't check because docs Uniswap. This one's right here. Okay, that's correct. So we're going to go to the replicate the Uniswap swapping smart contract here, and part of what this implementation does is we have. I want to show exactly what I mean by this. I saw that they may have changed the in the docs just between these couple of days because I'm not finding as I had them before. Like just yesterday.
Things move fast sometimes, huh?
Yes, it's crazy. It's crazy. I swear that I was just checking this yesterday. Anyways, the things that's really, I wanted to show is there's like these periphery contracts. That those are the ones that we are actually going to be using to, help us access the methods that the core protocol has without exposing us to the risk and doing calculations that might be tricky for us to implement on our own. So most of the times whenever we want to hook into this Uniswap protocol on our own smart contracts, what we need to do is communicate. Let's say this is going to be the strategy. which is usually like a smart contract on its own. You can think of it like that strategy. And that strategy is precisely going to interacting with these periphery smart contracts instead of the core protocol. So when we go to documentation and we see, let me close the white paper. When we see that we have some on the swapping quick start, we will be using the universal router, which is precisely a contract that will allow us to find some, like, find the pairs, find the liquidity that we need and the positions that are going to be available for us inside the swapping part. And that's the main smart contract that we will be using. So on the guide, we can see that they're using Foundry. We will be using Hardhat as that's our main, our main framework that we are currently using. And we will need to install several dependencies. So instead of doing this like so, we can, here's the ones that we're going to need to copy. I'm going to copy this, and we're going to move to our recently created folder, open it up. And here in our package, inside our Hardhat folder, we will go through the package.json file, yes. And here we're gonna copy and paste these packages that are the ones that we need. And we're just going to make sure to remove these remappings thing that is managed by Foundry. And we just need to, actually, since I'm not sure about the version, we're going to do this, okay? So we're going to copy all of them in just one single line, and we need to move. Since what we need to do right now is install these Uniswap packages. As if you remember from the previous session, what we had before, we were deploying smart contracts using OpenZeppelin's implementations, and that is because by default the scaffolded framework has them installed inside their the definition. So if you go to inside the Hardhat folder into the node modules, you will see that the OpenZeppelin package is already installed for you. Now we need, as part of the quick start, it's indicating us that we will be using the OpenZeppelin contracts. So we don't have to install them because we already have them, but we will need the Uniswap smart contracts. So that's what we're doing right now. We're installing these contracts. And for this, we need to install them by going first into our Hardhat folder. So right now we are on the root folder, and if we print the working directory, we will see that we are in the DevCamp week 2 session 2 folder, which is this one. So we are at this level. So we need to go one level into the Hardhat folder and execute the installation command. So first I need to move, change the directory into the packages/Hardhat. And here I will enter yarn install. And I'm going to, I copied another thing. So let's see if I can reuse this. There we go. And install all of this. Oh my God. I hate when it doesn't let me copy here. There we go. So we're installing all of these packages inside our Hardhat. This extraneous positional argument before core. I need to no, it's allowing this. We can find them on 9 p.m. ourselves. And install them. So there could be like a package. Maybe we need to download them. Yeah, the contracts. Yeah, I cannot. Contribution. I already have Forge installed, but I'm not sure if I can just do with Foundry like that. So maybe that's why we need Foundry directly. So it is installing. And it installed them on the lib folder. Okay. It's not ideal, but at least we're going to have them available. So that's good. And we need to install all of them then. And well, okay, what's that? What's Forge or Foundry? Foundry is the other framework that we have available for smart contract development, and it also comes with some utilities that are very useful. So that's what we're using, Forge. So yeah, maybe that's something that I had already done. So I already had this Foundry installed in my computer, so I didn't have to install it. But in case that you need to do it, just run this command on the Foundry book, and you run this first. Should install all of the packages inside your computer, and then you can just run Foundry up like this Foundry command, and that should allow you to use Forge, Anvil, and what was the other cast, which are like the cast, Anvil, Chisel, and the Forge command, which is yeah, helps you like manage all of this. So we're installing it instead of as a package as part of the library. So let's do that with the rest of the contracts. Let me see if I can do it like this. I think I can, but you can always try. So now we're installing all of the contracts, and I'm gonna leave them here in the root folder. Maybe I should have installed them inside the hard hat folder, but I don't think it's gonna be like a huge issue. Now, this is gonna be a tricky part for the importing. So let's move to our smart contract. We need to delete this one, which is the default one. And let's just copy this and see if the imports are correct. We probably need to, which one are we at? Whoa. V3 and V2 weren't able to, V3 core and V2 core had some issues there. Okay. Let's move this into hard hat folder. And the git ignore, I'm just gonna enter this as well. So the loop folder. And let's try once again, but let's just try the two last ones. V3 and V2. I'm also going to check if the universal router was installed correctly. Let's see. It's not finding this. I think that one exists. Okay. So how can we get the V3 and V2 core? Because I think we will be needing them. Some of them at least. Here I see only V4 and the permit 2. So maybe we're fine. And let's move to our contract and create a new swap example contract. That's all. And this is the thing. Let's see if I can find it correctly. Here. It won't worked. So maybe just like this. Okay. So let's see if this works. So now what I did was just install some of these packages into our library. We weren't able to install version 2 and version 3. We might not need them. I don't see any imports. I hope these implementations don't actually require any v3. And in the meantime, let's just try it out and see if we can compile this smart contract. It's not installed. Turn installed. Yeah, that's the issue. The v4 IV4 router. Something is happening here. Okay. So we still need to. It should be even more up. Yeah. So this might be a pain. Probably. Gonna need to switch a lot of those. Okay. Which one was it? Dispatcher.sol. It's gonna be hard to find. This one is at universal routers, contracts base dispatcher.sol. Universal router. Base dispatchers. It's gonna be a lot of them, I believe. Soulmate. Who's using Soulmate here? No, it's gonna be. Here's Soulmate. So we can. Right here. Okay. I fear that it's gonna be very rewards collector. Very uncomfortable. See. Universal router, contracts modules. What's wrong here? This is just a pragma thing. I believe. And this one. Okay. before periphery source libraries. Periphery source libraries. Path key, that's all. This is because it's using should go that no, it should just go one up. There we go. Each other. Periphery source interfaces. Immutable state. Universal router and rewards collector, that's all. Yeah, this might this might take a lot. And this one was contracts interfaces. Mm. Contracts, models in Uniswap 2. Yeah, this is the one where we need the Uniswap 2 core contracts.
Oh, you are gonna need them, huh?
Yes, this is a problem for sure. I mean, the other is we can just use Foundry, which could be an interesting approach, just so we don't stop here. Because yeah, this is a little bit of the uncomfortable part of doing some of the coding. These preferences happen sometimes with the how you call it with each protocol. If they are using something specific, it can be harder to move to the other framework. But yeah, let's just start with Foundry. It's been a while since I created a project with Foundry. I guess we could create one for. Let's see if we can do it, make it happen here. Session 2. Instead of that, choose npx, create the latest, and I'm going to choose session 2 camp. It's Foundry this way. So choose Foundry. There's probably gonna be like small things, but we should be able to just go through the docs. Where did I leave the docs? So this one is installing this, and we will need to run these forge commands as well. So let's switch to the Foundry folder. And we should have the same packages, but instead of a hard hat, now it's Foundry. And here's where I'm gonna run the Forge installation scripts. So hopefully we don't have any issues right now, and we need to make a switch. So here's like a way this remapping file helps us to let know Foundry which are the import paths that we will be using. So for example, in this case, instead of trying to import from add Uniswap v4 core, we will be importing from leave v4 core. I don't think Hardhat has this kind of, at least I haven't seen it. So that's why Foundry makes it a little bit more flexible for you to install the packages as we did inside the lib folder, and have Foundry let know the smart contracts that instead of pointing to npm package, you should be pointing to a specific folder that where we are installing these Uniswap contracts. So this worked. You one up, sorry. So now that we have installed, and this changes a little bit, but at the end of the day, smart contracts are still smart contracts. There we go. And it's still, we're still using Solidity. The only thing that changes is our tooling, but we'll still be looking more into the specifics that Solidity presents to us, the challenges. So after doing that, let's find the remappings file, and here's where we will enter this. There's a small conflict here. Well, you could say it's a conflict, because we have the Open Zeppelin contracts and we have these remapping before. So I'm just going to remove and keep the one that we just took from the Uniswap documentation, because probably that's how they are importing their contracts on their files. We just need to follow this the same nomenclature, whatever. Okay, so now that we have installed our, now I can switch back to how it was happening. We have installed all of this, and we have switched the remappings, and now we can once again remove our contract here and delete this, and create a new contract called Simple Swap. Copy, and here's what I meant. Like, there's something here happening on our remapping. So let's take a look at them. So Open Zeppelin contracts. Maybe it has to be like this. Yeah, there we go. Okay, so the previous one was okay. And let's see, what do we have here? Identifier is not a library name from Ripple Manager. Never seen this. So this is very clearly the one that they're using here. Using state library for. Let's see if we can. It's over here. So let's see. So let's see if we can. We need to do something else, and it's indicated. If not, we'll take a look. So we're importing the contracts, and here are some of the contracts and definitions. So the universal router is the interface that we will be, the periphery kind of contract that we will be, integrating with. So it provides a flexible way to interact with the protocols. Commands, definitions by the universal router. This is the one that interests me. The iPool manager is to interact with Uniswap v4 pools. Maybe we don't need this state library. I don't understand why is it not, doesn't show anything. I don't think it's gonna give us the answer. State library. Maybe I should import it from here. This one. Import state library. That's right. Okay, that kind of worked. At least it's removing us our. Let's accept this. And explicit type conversion allowed for non-payable to contract. This is a weird one. Explicit type conversion not allowed from non-payable address to contract, which has a payable. Maybe I can do this. It's like a casting thing. Yeah. So this is tricky, right? So right now we're diving quite a lot into implementations that, it's taking to the next level. Sometimes, I mean, to be honest, I'm not a super smart contract developer. I understand most of the things, but right now, some tricks that I've been learning every once in a while, looking for imports. At least we remove that warning. We will see if that works for the deployment. And then we're defining, it's kind of these syntaxes we definitely haven't seen. I hadn't seen before. We're just indicating that we will be using a state library for the iPool manager contract. So the pool manager is going to have like all of these implementations for the pools, and it's going to allow us to access some of the specific functionalities, such as the swap functionality. And it's using the state library, just some utility functions to get slot 0 to access the smart contracts memory or states, and get kind of a better the slot and the value that each it's just making it more efficient. I won't dive into this too much, just so you know that there's they're doing some cool solidity implementations and making it more efficient for gas management and memory allocation. Things are a lot more lower level that we will be using. That's what the iPool manager is going to allow us to handle all of this together with the state library without us taking care of all of these crazy things. And the permit to this is also like an implementation for a specific implementation for the permit to functionality that allows us to execute the approval as well as the transfer in the same just one transaction instead of two. This is a small thing that we haven't seen on the course, but it's just the approval and allowances thing that still works on the background. But with permit 2, you can do you can sign the approval, and that signature, once you send it together with the transfer, and if it allows the permit functionality, then it unlocks this allowance without you having to do first approve and then transfer. So right now that's the initialization that's happening. First, we're going to have to send over the router, which is a smart contract that exists on each chain, has its own universal router. That doesn't necessarily mean that each chain has the same smart contract address. So take be careful around that. Same for the pool manager and the permit 2. These are kind of like wrappers that I believe the permit 2 works. They're using as a wrapper, so you can use all of the functionality and implementation that exists for the iPermit 2 the implementation or standard. So that's what we're doing right now. We're just initializing 3 smart contracts that act as wrappers or as interfaces for our needs. So then we need to implement the token approval with permit 2. So if you want to get more information on what permit 2 is, here's like it's like a token approval meta transaction system to make approvals easier. Like you want to take a look, here's all of the like documentation, the different EIPs that were suggested and used. This is also part of like account abstraction improvements that, it's not specifically in that ERC, but it works towards that same goal. We're making it easier for transfers to be handled. So since we are want to allow token approvals to be implemented with permit 2, we need to make that happen before we can execute swaps. We need to ensure that we can transfer the tokens. So we'll implement like this wrapper function, or rather like a before transfer function that will allow the universal router to spend tokens on our behalf. So in other words, let's copy this function. Whenever a swap is going to happen, we will run this function first. So what we will do is make sure that any swap that wants to come through our smart contract has an approval generated, so we can easily, enable the same experience that we had on the Uniswap interface, where I just had to, we can do like once again very quickly. If I want to swap 5 USDC for this, so if you see first, actually I think I already have I have already given my approval, so it's just by. So, and the approval is probably, you see call contract now, it's already has like the approval set probably to max. That's what a lot of the exchanges and automated market makers do, just for simplicity. But let's say that we want to buy Chainlink, and Chainlink is one that I haven't given approval, or I given approval to USDC. So maybe go to Uniswap again, and we're gonna make it the other way around. I'm going to swap some Uniswap for USDC. So I'm going to swap this excess. And first, it asks me to review, so I need to approve and swap. So the first thing it's going to ask me is this approval. And as you can see, it says here that it's going to, I'm going to do the max. I can change this if I'm not mistaken. Here. So I can just ask to do 0.5. And no, it didn't enter. So I update this. And first I sign the transaction. So whenever this signature happens, this signature is sent straight away. The approval has been detected by the front end, and now this signature that is being asked here, this new one. First, we created the signature. That's what we did. That's what we signed, and then we will sign the transaction proper that does the transfer. And this signature includes the signature that we had before, like where we are approving. So they can decode it on the smart contract level, and it can transfer the function, like you can transfer the value without us having to call the approve function first, sign a transaction, and then call the transfer function and sign another transaction. So that's like the gist, and that's what happened here. We will pass, which is a token that we need to approve, the amount, and an expiration, which is also part of the permit to implementation. We need to give an expiration date, or it's like a time, an expiration value, which indicates an amount of time that's going to happen before this, it's an expiration. This signature is approval. So first, it uses the ERC20, so ERC20 implementation to call the approve function on the permit to. Why is it using this? Okay, yeah, it's using the permit to implementation to, and it's actually approving the max, as you can see here. Maximum value. So this is like by default, they usually do this. And the permit to approve is going to be doing the same, but instead it's going to be handling the specific amount and the expiration. Use permit to approve the universal router with a specific amount and expiration. Yeah, like one, exactly like that. So then we need to implement the swap function, and let's copy this and go and check what this one does. So pull key, I don't think this one's pull key struct. We might need this later. It's not being called. Not unique. You need to define that still. Okay. So our function signature, it's going to be receiving the struct that identifies the v4 pool. So this specific, here it is, the struct. You can copy this and define it over here on the top. We also need the currency one. So is this not being? No. See if it's also another library that we need. Oh, this is currency types, currency that's so. Okay. We probably need this one over there. Currency, and I hooks. Okay. Maybe I could have imported this, but I don't know where, if there's a definition already for that one. Yeah, there's actually one. No problems. So what does it send? The documentation that spanner function structure. This is a pool key struct. So the deadline parameter. Okay, so first we have the call data key that is going to instruct us which pool it's the one that we want to actually identify or like get information from the pool where we want to make a swap. The amount in and the mean amount out. This is the amount of tokens that you're going to deposit, or rather the amount of tokens that you want to receive. From this, I believe you have to enter one of these only, and the other one should be 0 because you're going to only be using one calculation to get the actual the other side's amount. So if you're going to deposit 10 USDC, then it will tell you how much you're going to receive, because that's going to be handled by the pool, not by whichever price you want to put. And the deadline is more of again, another expiration kind of variable. How should expire. And when swapping tokens involving native ETH, we use currency.wrap address 0 to represent ETH in the pool key struct. All right. So we need to send native ETH. Our currency will need to be defined like this. This is just like a note. Sorry about the dog barks. So encoding the swap command. Okay. Before going to this is another utility that we are using. I believe I told you that we have different ways to encode the, to move into bytes. So in this case, where we're encoding these swap commands, we are doing it because we need to send the information, the data that we're going to be sending to the smart contract. It needs to be encoded into bytecode that can more easily be read, and with a specific, rather than a structure, but it's precisely that. So the formatting needs to be well done and then encoded so we can actually execute the swap. Because if not, you try to enter like plain text, it's not going to work. So that's why we're using this ABI include pack, and there's the other function as well that decodes that we can use. And what is happening here, the V4 swap. So this is what I was mentioning before. The input swap is the one that you know how much you're willing to spend, and of course you will be given any amount of output tokens, and the output swap is the reverse. So all of this is encoding, and let me just go further so we can get the proper like chunk of code so we can take a look exactly into what it is. So here's the full implementation. Yeah, swap except single input. Yeah, input single. Okay, so here these commands before. And this one's not available here. Why not? V3 and V4 it's not available. Interesting. So these ones on the universal router. Which other commands we have available? Because this one doesn't have before. Two. Sorry, tests. So we have V3, V2, but not V4. That's weird. That's how to this. So what's a command that actually goes here inside this? Yeah, that's it. The issue, we don't know exactly which one it is. Permit to transfer from exacting is 00, but V8 is a different. So this is a little bit tricky because we don't have these are definitions of the memory slots where the smart contract code is actually located for these specific functions. This is like it's a library, so this is all hard coded. According to their implementation, these are the different memory slots that each version has the functionality available in. Unfortunately, we don't have the V4 swap here. So you have the V3 swap correct, but the V4 was not installed, and that's a little bit worrying. This one's for the universal router, but this one doesn't have. This part, maybe we can find V4 swap somewhere. It's only here. That's terrible. What are we missing in that case? Commands. Command. It's going to files. That's too much. 88 files. It's worse. It's a little bit better, but still not great. So the universal router is the one where we are already importing. I don't know why it doesn't show. Dispatcher. Yeah, we're not gonna be able to complete this apparently. I mean, we can try with different values, but I don't think it's gonna be like trying to. Maybe we can find it in here in the contracts themselves. So, pardon, GitHub. This is for all the Uniswap for V4 contracts. Let's see. I don't want to see the deployments themselves. I want to see the GitHub repo where I can actually libraries. So commands should be here ideally. Interfaces. Test, I don't think so, periphery. V4 router. Git source. Watchdog. We just need the command for V4 actions. Utils. Maybe here. Let's see. Use a unique encoding system for its commands and inputs, which is crucial for V4 swaps. Execute byte commands. Where is it importing it from? That's exactly what we're doing. Commands. We're Uniswap universal router, contracts, libraries, commands.sol. However, the problem here is that this command here are the complete list of commands. Let's see. Let's see if we can find V4 swap. Yeah, this is something wrong in the documentation. So V2 swap. Yeah, this is less than ideal because we are not gonna have that V4 swap. But on our contract, are we using commands anywhere else like this? Yeah, we're executing. Maybe I encoded from actions. So where is it? Up. Because then it's going to execute the actual command. And here in these actions, yeah, it's gonna pass these inputs, part of this. So we're gonna have to risk it, I guess. V3 swap exact in, V3 swap exact out. There's no V4 anywhere. Oh, here it is. So this is not up to date. Nice that we were able to find this. So we can copy this now. And on our commands folder, hopefully it actually works. There are a lot of things. Just copy the. I'm worried that let's just do it like this. And here, pool key, value type. I think I should be able to, in that case, keys key one. Pull the memory key. Maybe it is because I am doing this pool key, I'm defining it here. And we saw we were able to import it before. Like so. Perfect. And oops, one more thing. So I can convert from currency to contract. Maybe I can call this an address. And where you did this. For instance, it seems like it exists and we already had it here, didn't we? Yeah. That's not what we need. This should be an address, if I'm not mistaken. Currency to address. What is currency exactly? So here, currency definition and type currency is address. Balance of this address, no. Let's see what we have here. It's supposed to be an address. And wrap the currency before casting it into. Replace amount out with amount. Okay, that was a weird suggestion. It was using some of the utilities that it currently has. But it seems like our smart contract is finally working. At least let's see if it compiles. So let's try it here. Your contract, that's all. It's fine.
that's fine.
No, yeah, because this is the one that we deleted. So
I got it. That's a lot of effort there, Mel.
Yeah.
A lot of moving pieces, man. Good stuff.
Yeah, it's probably because of. But these are. Yes, that's all. Let's see what the actual package.json says here for Foundry. So whenever we run the compile script here on the root folder, it goes to jar and Foundry compile. So you're in the right one here. Make compile. I'm not sure where is it going through contracts, your contract. That's all in Foundry. Oh, in the test one. Okay. Test folder here. Remove this test and try again. I mean, the compilation looks like it worked. So just retry, and we shouldn't see that error anymore. Still find the contract that's all. Deploy your contract. Okay. It's on this script. Here's where it's trying to do this. And we should try that one. And this one doesn't take any argument, or what is it? Expected 3. Oh yeah, we need to find the 3 the 3 constructor arguments. So first the router, then the pool manager, and then the permit2. This should be available on the documentation as well. So let's see if we have some of the deployments here. So let's try in the meantime just Sepole, which is I have some tokens. Because we're gonna fork. We're actually gonna fork mainnet. So let's use the mainnet deployment. And or maybe we could do Polygon. Could be fun. So let's use Polygon. First, we need the router, the universal router, which is this one. So on the deploy, first pass the router. This address requested. Okay, handle that in a bit. Maybe I can do this. Okay. Seems like it's expecting it without. Yeah. No, it's still not working. Looks like the rest has invalid checksum. This is not this is an address. Now we need to. What's the problem here? We'll send a bit. So that's the universal 2. Then we also need. Sorry, the universal router. We also need the permit2, and before that, we need the pool manager. So first, let's copy the pool manager. And then permit2. I wonder if it's because it's not using the all the letters. Yeah, it's probably the reason. So minor thing here, we need to enter like the proper address because of the checksum thing. And the first one was the universal router. So don't use the one here. You have to use the one that has caps and stuff. Okay. So now should be good to go. L value tree compiling via IR step too deep. What is that? Uniswap v2 swap router.
It's like whack-a-mole.
Universal. Yeah, this is very crazy. Contracts modules Uniswap v2, but this is on universal router. Let's see. Leave. Oh yeah, it's actually universal. Leave universal router contracts. Contracts modules Uniswap v2. And which one? What was it? V2 swap router. And 940 recipient. What is this? Let's try it. Didn't like this. Unrecognized option via IR. Let's see. Debug this error when compiling. Seems like an issue on this is crazy. Okay. Foundry.toml should be here, and let's just do what it says. I'm gonna put here. Let's try again.
That
Invalid table header.
really didn't like that,
Okay.
huh?
Seems like this is already somewhere else.
Huh.
So it's okay. Yeah, that's a problem. You just need to put it up here together with this one. It says here duplicate key fault in table profile. So nice. Now it's finally compiled. And okay,
Good job, Mel.
here comes the tricky part. We will deploy this, but we need to use since we will want to test a proper swap, we need to use a fork so we can access the current Polygon liquidity. So I can like show you how it would look using this token. This smart contract that we just created for swapping, but how we can access our existing assets on the blockchain. So it's been a while since I run this, but should work the same because it's still scaffolded. So if I run Onchain, yeah, but I want to run Jan fork. And for this, I'm not sure how you fork on Foundry, or how you tell it to fork. Okay, should be very similar to the. So there's an Alchemy API key that's of course just for testing or for Scaffolded provides it, so that's very nice. And we can actually go and try Polygon here. So it was with Anvil. I'll just run this. Yeah, I run it, but I don't remember. So maybe with the documentation on Scaffolded 2 can tell us deploying, shipping your DApp. To fork. Let's see, how can I fork mainnet from Foundry? Let's see if this works. Yeah, with Anvil. Okay, perfect. Okay, I think it was then with but scaffolding to forking for testing. Let's see, because I know that if I run the Onchain command, so the package.json, make chain setup Anvil. Okay, fork Anvil fork URL chain ID. Okay, so the fork URL is going to come set up Anvil wallet, and then we do Anvil fork URL. Where does this come from? Maybe from the network. Okay, I need to provide the oh no. Okay. Okay, JSON. Let's just run fork then. Run fork. Okay. Yarn deploy. Okay. And then we run yarn start. So what's happening right now is I'm running a fork of mainnet. So that already is configured by default on Scaffolding 2. We just need to run the fork command, and inside, say, the Foundry, configuration, there's already kind of like these URLs. They have it ready to be used with the Alchemy API key. And whenever you run the fork command, you can I'm just wondering where this fork URL comes from. So yeah, you would need to, if you want to switch, for example, to Polygon, I would need to put 137 and Polygon, and that way it would work. But let's just keep it like that in the meantime and explore our localhost 3000. And here we should see our scaffolded next JS application, which is the one that we will be working on next week. And maybe since I will be using some real balances from mainnet, I want to connect with my Foundry and connect with my wallet. Okay. So now, as you can see, it indicates that I have some Ether, which is the same that I have here. Yeah, 0.0728. And that means that we are forking the network correctly. So I should have access to the smart contracts to smart contract here, number one, simple swap. And I believe we used Polygon for this one. So we actually used the smart contracts, the deployments, yeah, on Polygon. So we are actually forking right now the incorrect network. Let me kill this this fork, and now I'm going to actually see if this works as I think it should. So now we should be forking chain ID 137. Okay, seems like it's working. And let's go back here. It's definitely 2. Okay, so remember these private keys and all that's been showing. This is all generated by Foundry. Don't send any money or any value here because it's gonna be, they are public private keys, so don't use that. So now I've done it again, and actually should come here. And now if I disconnect, yeah, you can see that now I'm getting 405.2657, but it's actually Paul, since we are using Polygon mainnet now. So let's try to make a swap. So for this tick spacing, I'm not sure how to actually execute the swap for this. I would say that we need, of course, the tokens that we want to swap. So we need to enter these values. The fee that we are willing to use, we probably will be safe if we use, USDC for, I don't know, a DAI or USDT or another stable coin. And let's use Glow Dollar. The fee should be the lowest because usually stable coins are paired with the lowest fee because of the low volatility. The tick spacing is the one that I'm not 100% sure which is the value that we should be putting. Tick spacing is just like a discrete definition for Uniswap liquidity curve. So let's see if we can. Well, I'm so sad because there were some very, very good resources that I was taking a look into. Yeah, this math, that kind of things. So ticks are like, you can think of a definition. It's a definition of what are the smallest intervals that you can have between this price curve. So it's like trying to split the time into seconds. So what is the smallest amount of time? You define what kind of discrete values you want to select between the price curve. So whenever you want to actually define this tick spacing is part of that. Like, so I'm not sure this one what it is precisely on the context of this swap exact single input. Let's reread the documentation to have that reference. So it's here and tick. Notice ticks that involve positions must be a multiple of tick spacing. Yeah, I'm not 100% sure what that means. Tick. And this only here. However, the pool key struct might be able to tell us a little bit more. Anyways, so let's find some token addresses: Polygon, USDC contract address, and Polygon Glow dollar contract address. So here's Glow dollar, which is another stable coin that I actually suggest you to use. This one's for earnings go for public goods, so that's very nice. And we will also use the USDC one. So this one. So I have some USDC. I should be able to access this. I believe the fee was put as what's it called in English? So I saw it before somewhere in another contract that they were using 3,000 for the 0.3 fee. So that's why I'm using 1,000 for the 0.1% fee. The tick spacing, yikes, this is Let's see if I can find what to use for tick spacing before. Tick math. Okay. Okay, amount output data. And this is also from the one that we are using. Tick math. Seems like we can use one, but maybe I'll use 10. I'm not sure what that is on this context. I believe it's just looking for the range that it can actually move between. So if we use like a very small range, it might check for more, intervals, but it's also going to be more costly on the gas. Let's not worry too much about that. And we're still using like a fork, so just going to put one. And hooks, I think this one should be, yeah, this one's not required. Or it's not that it's not required. Let's say amount in, and currently I have on Polygon 117 USDC, so I should be able to get, I don't know, it's, however, this is USDC, so the decimals are not, maybe I should do something like this. Address is invalid. I can put the 0 address. Don't remember how long was this. It's supposed to be 40, right? Yeah, maybe swap accept input single return no data. This is not the error. This is the contract function swap return no data. This could be fun. Consummate function. The address not a contract. Okay, maybe let's try like this. Number is gonna save 24 bits here. Okay, so small issue here because I'm not sure what the hooks one is, but yeah, we can stop until here. It was actually interesting to go through all of that cutting for the swap, but right now we are missing something on the pool key. So let's see, Uniswap example pool key struct. Yeah, this doesn't help a lot. Source. This is not. Store contain details about the specific units of the liquidity pool to use for the swap, including token address, fees. Yeah, this is the issue. We need to find this pool key with the proper information. It is live. Let's see if we can find what they're using here. Pool data. yeah, the pool key, and let's see if there's like a deploy script we can. Token. No, this is using another kind of pool swap test. Deploy. Trying to find if we can find a proper pool key, but I couldn't find it. Yeah, we're gonna stop here for today. We're almost there. It's just a matter of finding out what is the actual pool that we need to access so we can actually execute a swap. Here, there's something probably regarding the addresses or this hook call, but other could be that we need to approve. Maybe, let's see, token. Duration, yikes, what should I put? Milliseconds, seconds, tomorrow, no. Yeah, it's gonna be tricky. This I'm not sure how to put the how much time current time in milliseconds. Tomorrow. Okay, let's see. Yeah, we're gonna cut it here, okay, because we need to do a little math and do kind of stuff.
Hey, you got the contract compiled.
Yeah.
You found the hard parts. You're making progress. Like you warned
Exactly.
us. This is where we get into the weeds. This is where we get into the difficult stuff. So I can see that firsthand.
Yeah, it's definitely tricky, but yeah, let's stop there. I'll work on the implementation so we can actually show a video of us executing a swap, at least on the fork, and have a much more cleaner repository for next week, because we will be diving into this front end and start creating these front end components for our current application. So we can start thinking on how to call smart contracts on an interface, how to call our different, import the contracts that we are deploying, and use what Scaffolded already gives us to make it easier for us to integrate them in our front end, and do some fun, debugging, but also on a much more UX experience instead of just going through code on the terminal.
I like it, Mel. We did not plan this today, did we? But we're wearing our matching shirts here. So big shout out. Yeah, big shout out to Dabl Club and just everyone that had time to spend with us. I just got my pizza warmed up. So I'll be doing my pizza day in a decentralized manner today. I'm here in the lonely deserts of Utah. So there is no party nearby me. That doesn't mean I won't have a party here on my own. So Mel, thanks for the effort. I know that this is some difficult stuff here, so we'll look forward to those little snip videos where we can get into this and get that front end put together for next week.
Yes, definitely. And next week, just we will be moving more towards front end, so less solidity, but this still we need to, we'll probably go through another quick round of implementation and going through our code on Solidity for next week. So in case that you find some questions or anything, and then we go into React and JavaScript.
I love it. Dabl.chat. Drop that into your address bar and it'll pop you right into our Telegram group. And that's where you can find other dabblers that are following along with the DevCamp, as well as myself and Mel, the whole Dabl Club team. We're there to answer any questions, support you. As Shruti said, she's got to rewatch it. Is awesome. But it was tough, and that is the whole point. That's why this stuff's not easy, and that's why everyone's not doing this kind of material. So we appreciate you taking the time to try to learn more and expand your boundaries and dabble here with us. And again, woohoo to pizzas. Happy Pizza Day to everybody. Thanks for dabbling with us, and we will see you at the next episode of the Dabl Club DevCamp, which will be next Tuesday. Have a great pizza day. Have a great weekend.
Thank you, guys. See ya.